as section 1.1 for Calc survey. What is a function? Now, I know you're going to look at that and say, seriously, we signed up for calculus, but please realize that chapter 1 is going to be a bunch of random sections and topics, but they are all so important. So you really need to make sure that you are staying on top of chapter 1. And it's a long chapter, but it builds a foundation to all the other topics we're going to eventually get to. So bear with me here, and we will get to some new topics in chapter 1, but these first couple of sections you might think, what's going on? But just to refresh your memory, this will be quick. So what is a function? Just to remind you, this is what function notation looks like. That f of t is how we say it. So the function p equals f of t represents the population of Carmel High School as a function of time. Now, remember to watch out for that of time. Usually what follows the of is going to be your independent variable. So p equals f of t, p being your dependent variable, we're going to talk about that in a minute. That represents the population of Carmel High School, and depending on what year it is, that's going to tell us what the population is, which hopefully makes sense. So what is the independent variable? Time. And again, watch out for what follows the word of. What is the dependent variable? Well, depending on the time, the year, that's going to be the population. So that's your dependent. And time is almost always going to be your independent variable. What does the statement f of 2010 equals 4,516 mean? Use correct units. So anytime it says interpret, you'll want to use your units to help you do that. So in 2010, the population was 4,516. I could have put students to be a little more clear. So one thing to note, watch out for when it says things like since 2000, since the year 2000, that would be t equaling 0. So if I had done that, I would do f of 10. So be careful with that. Yeah, your book likes to do that a lot, and so do I. What might a graph of this function look like? So I would think since Carmel High School opened, we've obviously increased drastically at times. So notice I didn't start at the origin because when Carmel opened, we didn't have 0 students. So I started a little off the origin, increased. Now you could argue linearly, I mean, lots of variations of this graph. So I made it a nice curve, giving it a little exponential growth. Now hopefully we're around this area here, but notice I leveled it off because we're not going to keep growing like we are. And then it could even decrease a little bit in the future years. So interpret the meaning of the vertical intercept. So that's again the population the year CHS opened. I don't want to start it at the origin. We didn't have 0 students. And then if the graph had a horizontal intercept, what would that represent? So this graph would, I mean, eventually, hopefully never, cross the x-axis, and that would of course be when the CHS closed, when the population is 0. Because remember, your x-axis represents time, and your y-axis represents the population. Okay, now, example 2. Here's where you're like, oh, okay, I've seen this before. So this is what you're more familiar with. So let y equal f of x, which of course these are the same things, equal x squared plus 2. So find the value of y when x is 0. So of course just replace x with 0. 0 squared plus 2 is 2. And then what is f of 3? Now notice a and b are it's the exact same problem. We're just plugging in different values for x. So when you plug in 3 squared is obviously 9 plus 2 is 11. And you can see that over here on the graph. So when x is 0, y is 2. When x is 3, so come out here 1, 2, 3, you're going to have a much bigger y value at 11. So obviously I graphed our parabola over here. Shifted up 2, and then it's just a nice parabola. All right, now see what values of x give y a value of 11. Okay, so this time we're going to set our function equal to 11, which you see here. So now you would subtract 2, square root both sides. Now don't forget, when you use the square root property, you have to put in that plus or minus. So that's what's happening. And you can visually see why. If you were to draw a horizontal line at 11 and continue our curve up, it's going to eventually hit our curve twice, -3 and +3. And then lastly, are there any values of x that give y a value of 1? Well, visually, you can already see no. If I put a horizontal line at 1, it's never going to cross the curve. But algebraically, we can see that when you set it equal to 1, subtract over 2, you get -1 equals x squared. When you go to take the square root, you can't take the square root of a negative, and you'll be happy to know we do not do imaginary numbers in this course. So we just say no solution. Okay. Then finally, increasing and decreasing. Think of yourself walking from left to right. If you're going up, the function's increasing. If you're going down, going from left to right, if you're going down, then the function's decreasing. Now, that seems simple, but that is actually a really important concept that we're going to carry through for basically the rest of the year. So, okay, well, please email me if you have any questions, and until next time.